everybody, myself I am Vaisali. I am going to deal with the 5th semester BSc course Database Management System, in which I am going to tell you about the second unit, which is called as the Entity Relationship Data Model, in which I am going to discuss about these various topics, which include reducing the ER diagram into tables, the enhanced ER model, specialization generalization, attribute inheritance, multiple inheritance, aggregation composition, and entity clustering. The module, in this module, the module outline would be how to reduce the ER diagram into the tables. That is, how to convert the ER diagram into the relational data model, which includes different steps. That is, how to convert the entities into tables and how to convert the attributes into the columns, or how to convert the multi-valued attributes into the new tables, also converting the weak entities, followed by the representation of one-to-one, one-to-many, and many-to-many relationships. Let us start our discussion with the first question, that is reducing the ER diagram into the tables, or it can also be called as converting the ER diagram into the relational data model. So, a ER diagram, it gives a good knowledge about the information and mapping of the entities in it. What does an ER diagram tell us? ER diagram gives us what are the basic entities that are required for us and also the relationship in between them. We can easily convert those into tables and required number of columns. We can convert each entity that in the ER diagram into a table which has a number of columns in it. Using the ER diagrams, one can easily create a relational data model. With the help of these ER diagrams, I can definitely and easily create a relational data model, which is nothing but the logical representation of the database. There are various steps which are to be used for converting into the ER diagram into the tables with number of rows. Each type of entity, attribute and relationships in the ER diagrams are having its own representation. Now let us consider an ER diagram and see how it is being converted into the tables with rows and columns. Now consider this ER diagram. So in which I have considered four major entities which include student, course, lecturer and subjects. Student, course, lecturer and subjects, in which student, course and lecturer are called as the entities, and the other entity, subject, which is being placed in the double rectangular box, is called as a weak entity. The entities are being represented like this in the rectangular boxes. We have four entities in our ER diagram, which include student, course, lecturer and subject, among which student, course and lecturer are called as strong entities and subjects is called as weak entity. Why is a subject considered as a weak entity? A subject is considered as a weak entity because a subject is always based on either the lecturer entity or the course entity. The subject entity is always dependent on the course entity because based on the course only the subjects will come for the student. And always the subjects are being handled by the lecturer. That is why here I have considered the subject as a weak entity. These are the four major entities which I have considered, and if we observe the diagram carefully, surrounding these four entities there are various attributes which are being represented in ovals. Anything surrounding the entity which is represented in a oval is being considered as an attribute. If we look over the diagram, for every entity has its own attributes. For example, in the student entity, I have student number, hobbies, age, student ID, address, etc. as the attributes. Followed by the course entity, which include course ID, course name, etc. Again, in the subject entity, I have subject ID, course ID, subject name, etc. In the lecturer entity, I also have lecturer ID, lecturer name, etc. included as attributes. Anything that is being represented in the ovals are being considered as attributes. Now coming over these attributes, there are various things to be discussed about the attributes. These attributes are again divided into 4 to 5 categories, which include simple attribute, single valued attribute. Let us first learn about the simple attribute and the single valued attribute. All the simple attributes and single valued attributes, they are represented with ovals. They are represented simply in the form of ovals. In our example, student ID is called as a simple attribute. Also, date of birth is also called as simple attribute or also a single valued attribute. Considering the other attributes, let us consider the third attribute, which is a composite attribute. The address here is considered as a composite attribute. Why is the address considered as a composite attribute? Because in the address we have internal divisions inside, which include door number, street, city, state, pin, etc. As we have internal divisions inside it, the address is being considered as a composite attribute. This is the third type of attribute. Now the other attribute to be discussed is about the fourth attribute, in which it is called as a derived attribute. What is it? A derived attribute. A derived attribute is represented with a dotted oval. A derived attribute is represented with a dotted oval. Here age is considered as a derived attribute because I can calculate the age if I know the student date of birth. If I know the student date of birth, definitely I can calculate the age by getting the difference between the current date and date of birth. I can calculate the age. That is why age is called as a derived attribute and it is being represented with a dotted line. Now the other and the last attribute to be discussed is about the multivalued attribute, which is nothing but hobby. Which is nothing but a hobby. It is again represented in a double oval. It is represented in a double oval. Why is it being represented in a double oval? Because a student can have single hobby or he can have more than one hobby. That is why a student he can have a single hobby or one other student can have more than one hobby. So such attributes are called as multivalued attributes, which are represented with double ovals. These are the 4 or 5 types of attributes. Again, a quick review of the attributes. What are the 5 attributes? Simple attribute, single valued attribute, are normally represented with ovals. Composite attribute, which has internal divisions, which include here our address. Now the derived attribute is the age attribute, which is represented with dotted oval, which is being calculated from the date of birth attribute. And the last one is the multi-valued attribute, which is nothing but a hobby attribute, which is represented with double oval. And this is about the attribute. And one more important thing to be discussed about the attribute is, in the attributes, we have one major thing to be discussed, which is called as, or which are called as key attributes. For every entity, definitely we will be defining a key attribute, which is being represented in a oval and a line underneath that attribute. Key attributes are represented again in ovals with a line underneath it. So in the student attribute, what is the key attribute? Student ID is the key attribute. In the course table, course ID is the key attribute. In the subject table, subject ID is the key attribute. In the lecturer table, lecturer ID is the key attribute. These are called as the key attribute. This is about the various types of attributes, followed by the various relationships in between the different attributes. See, I have been representing the relationships in between various entities. Student and course. There will be many students learning many courses. That is why I have represented a many-to-many relationship between student and the course. Also followed by student and lecturer. Student and lecturer. So this can also be a one-to-many relationship. Many students teaching, many students learning or listening to many number of lectures. Also a one-to-many relation or one-to-many relationship between lecturer and subjects. One lecturer can teach number of subjects, or one lecturer can teach one subject. Also course and subjects. One course handles number of subjects. For example, in BSc Maths, Stat, Computers, we have subjects Maths, Stat and Computers. In BSc MP Computers, we have Maths, Physics and Computers. Like that, one course handles different subjects. Also, we have a relationship between lecturer and the course table, which is again a many-to-many. Many lecturers handling many number of courses. This is the overall ER diagram. Now I am going to convert this ER diagram into the relational data model. So there are basic steps which are required for converting the ER diagram into the table are as follows. First thing, convert all the entities in the diagram to tables. What are the major entities that are present in our ER diagram? The major entities include student, course, lecturer and subject. These are to be converted into the tables. So in our relational data model, I will be getting 4 tables. What are those 4 tables? Student, course, lecturer and subjects. 4 major tables I have got. Now what should I do? I need to define columns for each and every table. For each and every table, I need to define the columns. Now let us consider the first entity or first table, student. What can be the columns in the student table? all the attributes surrounding the student entity here are considered as the columns. All the attributes which are being surrounded by the student entity, which includes student ID, student name, address, phone number, etc. These are called as the attributes which are here considered as the columns for the student table. Similarly, in the lecturer table we have lecturer ID, lecturer name, etc. to be included as the columns of the table. Key attributes. The key attributes which are in the ER diagram. What are the key attributes? As I have already told, the key attributes are represented in oval with a line under that. Is it or not? So those are called as the key attributes which are here in the relational model considered as the primary keys of the table. They are being considered as the primary keys in this table. Now let us discuss about them. In the diagram, the student ID, the lecturer ID, the course ID and the subject ID. These are the key attributes for every entity. For student entity, student ID. For lecturer entity, lecturer ID. For the course entity, course ID. For the subject entity, subject ID. These are the key attributes which are here considered as the primary keys of the four tables. Now, if we define the primary key in one table, that primary key can be used in the other table or it can be used in the other table as a foreign key. The primary key of one table, it can be used in the other table as a foreign key, and this foreign key is being used to establish a relationship in between the tables or a relationship in between the entities. If we observe the ER diagram, the course ID, it is being used in the student entity. In the student entity, I am going to obtain the course ID, wherein which course ID is declared in the course entity. Also, we add course ID in the student table. So, here I can add the course ID into the student table as the foreign key. In the similar way, in the lecturer table also, I add course ID plus subject ID. These both together are being used as the foreign keys in the lecturer table. So, these foreign keys, they are being used to establish a relationship in between the tables. After this key attribute, let us now discuss about the other attributes, the various types of attributes. Let us consider a multi-valued attribute. What is a multi-valued attribute? As I have already told, a multi-valued attribute is represented with a double oval. That is a hobby. How to represent the hobby? How can we represent these hobbies? As we cannot represent them directly in the table, these multi-valued attributes, they must be represented in a separate table. A hobby in the student table is a multi-valued attribute. Any student can have number of hobbies. So we cannot represent that multi-valued attribute in the student table. We cannot represent that multi-valued attribute in the student table. So what should I do? I need to separate that hobby and put it in I need to put it separately in another way. What do I do? Adding, removing or deleting hobbies may create some problems or anomalies in our table. So what should I do? I remove that multi-valued attribute and I define that multi-valued attribute in a new table. So I create a separate table for the student hobby. Separate table for this attribute which is called as student hobby. So I create a student hobby table. So in which I will be adding student ID as the foreign key. In which I will be adding student ID as the primary key. So this is how I separate the multi-valued attribute and put it in a new table. Any multi-valued attributes, if they are present in the ER model, they should be defined separately in new table. That is about the multi-valued attribute. Now coming with the composite attribute, what to do with the composite attributes? Composite attributes also have the same problem. Composite attribute also have internal divisions inside it. In our example, I have considered the student address as a composite attribute, in which I have door number, street, city, pin, etc. So again, this also should be separately placed in a new table. So instead of defining two new tables for one for multi-valued attribute and one for composite attribute, what I do is I combine these both and put it in a new table, student hobby. So I define student hobby in a separate table, wherein which in the student hobby table I will be using the student ID as the key, the primary key, and followed by the student hobbies and also student address included in this. So after that, this is how, after using all these basic rules, this is how the ER diagram is being converted into. So the structure includes four major tables. What are those? Student, lecturer, course, and student hobby. Student hobby is the new table which I included. So in the student table, student ID will be the primary key. In the lecturer table, lecturer ID will be the primary key. In the course table, course ID will be the primary key. And also in the student hobby table, I will have the student ID as the primary key. Now let us see some special cases which we have to discuss about this ER diagram. One thing is, if you remember the previous ER diagram carefully, we have observed that we have considered three entities. We have completed discussing about three entities. What are those? Student, course, and class. Lecturer we have completed. What I have left is subjects. I have left one major entity, subjects, because it is a weak entity. So weak entities, they should also be represented in the form of a table. A weak entity should also be represented in the form of a table. All the attributes in the weak entity are considered as the columns of the table. But what is the major thing you have to represent? A weak entity, it should have the key attribute. It is represented in the diagram. It cannot be the primary key of this table. That is, what is the weak entity here? The subject. In our ER diagram, subject is the weak entity. So we create a table for that. But its attributes should be subject ID, subject name. Along with that, I should use, along with the subject ID, I should either use the lecturer ID or the course ID. I should either use the lecturer ID or the course ID to make this subject ID as a primary key. So here I cannot directly define the subject ID as the primary key. I need to combine the subject ID along with the lecturer ID or along with the course ID to make this as a primary key, which is here called as the composite primary key. What is it called? That becomes a composite primary key. Hence, the primary key, course ID of the course is added to the subject table as the foreign key. Now, we create a composite primary key out of course ID and subject ID. Course ID plus subject ID put together, it becomes a composite primary key. See the diagram in which the course ID in the course table is the primary key, wherein which I have used this as a foreign key in the subject table. Wherein which in the subject table, subject ID plus course ID both put together, it becomes the composite primary key. This is how we define the various entities and attributes. Now coming over, the last thing to be discussed is the various types of relationships. How are the relationships represented? The representation of relationships are of three types: one-to-one, one-to-many, many-to-many. Let us now discuss about representing a one-to-many, one-to-one relationship. Imagine the student and lecturer. The relationship between the student and lecturer is a one-to-one relationship. Imagine student is not a weak entity. We have a lecturer who teaches subjects. So there is a one-to-one relationship. One lecturer teaches one subject. So how can I represent this? I can represent it with this diagram. How is the diagram represented? Look over the diagram. The lecturer and the student. And the subject, sorry. Lecturer and the subject. Here in the subject table, I have subject ID, which is being used in the lecturer table as a foreign key. Or from the lecturer table, I consider the lecturer ID and I will be using that as a foreign key in the subject table. Either this or that can work out. It can be represented in both the ways, wherein which it is being used to establish a relation or an association in between lecturer and the student table. Either the subject ID in the subject table can be used as a foreign key in the lecturer table, or the lecturer ID in the lecturer table can be used as a foreign key in the subject table. This is how I can represent a one-to-one relationship. Now coming back, the next relationship is one-to-many relationship. How to represent a one-to-many relationship? Consider subject and lecturer. What is the relationship in between subject and lecturer? I consider one lecturer teaches number of subjects. I am going to consider one lecturer teaching number of subjects. So in this case, the primary key of the lecturer table is being added into the subject table. That is, the primary key of one cardinality entity is being added to the foreign key as n cardinality. And one lecturer can teach n number of subjects. A lecturer ID in the lecturer table, he can go and teach number of subjects. So, the lecturer ID in the subject table is being used as a foreign key. This is how I represent a one-to-many relationship. After that, representing a many-to-many relationship. How do I represent a many-to-many relationship? Now consider again the example in which the student and course. The student and course. A student or many students will be learning many courses. And this is the most important relationship to be known, and this is the very difficult relationship to be implemented. This is the most difficult relationship to be represented. So what should I do now? Because in both sides there are number of students as well as the number of courses. How to represent such many-to-many relationship? What I do here is it is very difficult to implement a many-to-many relationship. To come over that problem, what I will be doing is I am going to break this many-to-many relationship into two one-to-many relationship. How can I break this relationship is by considering a third entity. By considering a third entity which is being placed in between these both student and course. The third entity I am going to consider is the student course entity. So look over the diagram. The student course entity. I am going to break the student and the course many-to-many relationships into one-to-many relationship by considering the third entity which is called as the student course entity. The student table, from the student table I am going to consider the student ID and I am going to use it in the student course table. Also from the course entity I am going to consider the course ID and I am going to place it again in the course student course table. So the student course table has two attributes combined together as a composite primary key. What are those? Course ID and a student ID. This is how I represent a many-to-many relationship. This is the most difficult relationship to be implemented. So to implement this, I am going to break this into two one-to-many relationship by considering the third entity. So this is how we convert an ER diagram into the tables, and this will be the module summary in which I have been telling about the conversion of an ER diagram into the tables, which include converting the entities into tables and also converting the attributes into the columns of a table, followed by the representation of a multi-valued attribute and the composite attributes in the tables, and also how to convert a weak entity, followed by the representation of the various one-to-one, one-to-many and many-to-many relationships. Hope you followed and understood what I have told. Thank you.